there printing. Hey guys, silent 3D printing. What a sound idea that is. I mean, would it be nice to turn all those noisy original Ender 3 into almost silent machines so you can print undisturbed for hours to come? And while literally everyone else is tackling speed of those printers to decrease the amount they are in operation, I decided to take another approach and figure out what is the best way to, well, keep them quiet. And I know some of you will say, well, what's the big deal? Just put the 3D printer in another room, close the door, and you don't have to worry about it. It won't disturb you and you can print all night. But it's a nice problem to have actually, because let's face it, not everyone is graced with space, and well, I've seen setups of 3D printers in kitchens, living room and whatnot. So if you're going to run the 3D printer for several hours, why not to make it as little disturbing as possible? And the good news is that I managed to rope in two partners for this video. Noctua, which is famous for quiet fans, which is, well, very suiting for this video, so you should definitely check them out. And BIQU, responsible for BTT 3 series of SKR quiet or silent boards, which, well, let's face it, considering the title of this video, they will come in handy. To silence your 3D printer, you can take two ways. First one is to build a soundproof enclosure. But even if you're gonna use lug tables, which cost about £6 each as your base, the costs of actually building an enclosure and noise proofing it racks up really quickly. The second approach is to start modifying your printer so it doesn't sound like the original Ender 3. And you can imagine this gets annoying very quickly, especially if the printer is, well, next to you, like in my case. And while building an enclosure it's a good idea, it does require extra space because you will end up increasing the footprint of the printer. Well, we gotta focus on the second idea, upgrading the parts to make it as compact as possible so you could keep it next to you and enjoy a bit of peace and quiet when that print is going. Instead of just throwing money to fix the problem, I came up with an alternative. I'm going to do it in stages. This way, after every upgrade, I'll be able to evaluate the cost of the upgrade versus how much silence it actually gives you. And you'll be able to decide whether you want to continue with something like that or not. But don't worry guys, in the last stage we're actually going to throw the money at the problem and see if it was worth it. The two printers that I own are Ender 3 and Ender 3B2. I actually have the Ender LD002, but this is a resin printer and I don't think that's going to be very well suited for this video. So, but if you're interested, I have a little bit more about this printer there. So those are the printer, and my first step was actually to strip down every single upgrade I've made so far. And that made me quite upset because I couldn't use any printing and I was, well, enjoying my quality of life improvements on those printers. And for the sake of having a benchmarking device, I need to get rid of it. I absolutely forgot how miserable the printing experience can be on original Ender 3 without any add-ons. So in my benchmark I'll show you how loud the stock configurations are in a homing procedure and in a printing procedure when the part cooling is enabled. So let's start with the original Ender 3. Equipped with 1.2 version Creality board, this thing is really noisy. I don't think we can blame anyone for looking for some solutions to the noise problem, eliminating the stepper whine and trying to make the whole experience slightly less noisy. So how about Ender 3 V2? It already comes with a quieter board, but for the most part it's a very similar machine, so let's have a look how that actually stacks against the original Ender. And you can already tell that the printer is much quieter, however it's nowhere near silent, and for the most part you are getting rid of just the coil whine from those stepper motors in move. It's a huge benefit, but I think we can do much better. Before we're going to start upgrading and buying upgrades, let's take a look at the sources of the noise on the 3D printer. First of all, fans. There are 4 different fans fitted in both machines. There is a PSU fan, the power supply fan. We also have extruder fan, that is usually always on. There is a case fan, which is cooling the electronics inside. And there is a part cooling fan, which usually is controllable by the motherboard and printing process. And as the Ender 3 V2 confirmed, there is a noise coming from the controller board itself and stepper drivers. So this is something we'll have to address too. Lastly, there are mechanical noises which come from moving elements, and those are very hard to eliminate, and probably we're not going to tackle them at all. When it comes to reducing noise on a 3D printer, the first idea I've come across online on Reddit and multiple posts was fit Noctua fans. And I was really keen on doing it, hence me reaching out to Noctua to help me out. And that's what we're gonna do. We're gonna fit a couple of Noctua fans and see if it makes any difference and whether you should invest in those as well. And that's what we're gonna do. We're gonna fit a couple of Noctua fans and see if it makes any difference and whether you should invest in those as well. However, this is not as simple as you may think. First of all, even though Noctua has a really broad range of fans, they do not offer radial fans at the moment, which means we won't be able to replace the part cooling fan, which on both printers it's a radial fan. That's fine because we're gonna tackle that later on. For now, let's just focus on replacing what we can. I've started with my Ender 3. Swapping the extruder fan was very simple because Noctua already offers you a compatible fan. This is a 4x10, which is the thickness of the fan, and it will simply fits right in. Another thing that you have to be aware with Noctua fans that they are running either 5 or 12 volts, and usual power supply from the Ender 3 printer series, it's a 24 volt power supply, so we're going to need a step down module. And since I want to have more particular control over the fan speeds, and I won't be able to get that from a fixed 12 volts, I've requested Noctua to send me the PWM controlled module, which is NAFC1. That way I'll be able to trim the speed of the fan to my liking and verify if there is enough flow to carry out the design performance. Now you don't really have to use those, but I have them to easily adjust my fan profiles so I could demonstrate what kind of silent levels you can achieve. Power supply comes with 60mm fan, which is 10mm in profile, and Noctua didn't really have a compatible fan at that size, but I do have a 20mm version of it, which means I can't just pop it inside because you will collide with some components inside, but I can remove the grill and run it from outside. If you do want to make it look neater, you can obviously 3D print a cover for your PSU and replace it with more suitable cover that will accommodate for the difference in fan. after opening the power supply, I discovered that this fan is simply connected to 24 volts inside my power supply via GST connector. Now, swapping that out was actually quite simple, but I've discovered a warning on the PSU saying that this fan will stop running if it's not needed. That turned out to be a lie, because that connector always has power and the fan is always running. So I went against all warnings and I decided to connect my step-down power supply, that's 24 to 12 volts, into that very JST socket instead of hooking up to 24 volts terminal. And it turns out that it works alright, so I guess that plate is being used on all of the supplies, even those that don't have that control circuit. If you find out that yours has a switch and disables the power and the fan isn't needed, then you'll have to hook up to the regular 24 volt pins at the bottom of the power supply. I've used the drill and a couple of standoffs to mount the PCB, and later on I'm probably going to print a cover for it so I don't suffer from accidental shorts. To connect your Noctua fans, you'll have to find your power pins. As I have PWM options of the fans, I have 4 pin connectors. Now only 2 are being used, and in this case I'm using the NAFC1 PWM signal controller so I could reduce the fan speed and control the loudness and flow of the air inside the PSU. But if you're interested, all you have to do is just supply the power to the yellow and black. Black being negative and yellow being positive. After that my work was complete and the fan was actually working quite well. Now I know it looks like something that is about to explode, but well, that's its charm. And if you wonder why there is a Shelly 1PM inside, then check out this video about enabling and disabling your printer remotely or with voice control. It's an upgrade you probably want to make yourself. The last fan is also A410 and it goes inside the electronics box, so it would keep everything cool. Now the replacement quite simple, however you have to remember you will still have to power it via 12 volts. Fortunately the PWM controls on Creality boards require negative pin as a PWM signal and positive as supply of voltage. It means that instead of connecting it to the 12 volt power supply, I can split that cable and connect the positive to my 12 volt power supply and the negative to the controller board. That way the controller board still will be able to turn on and off the power supply, and the fan will be getting only 12 volts. Win-win. As I already mentioned that Noctua doesn't really do radial fans, at least not right now, we're going to leave a part cooling fan where it is. This upgrade will cost you approximately £45 if you want to exchange all possible fans and add 12 volts power supply to your printer. So let's see how well that worked. I have to say that the results are really disappointing and there is absolutely no reason to do this. Well, at least not in this form. After disconnecting all fans to verify that my theory behind it is right, I can confirm that the entire sound, the majority of the sound on that 3D printer comes from the board itself. It's the chopper setting to chop the current in the correct chunks to drive your steppers. It's really noisy, even when it's just enabled to hold the torque on your stepper motors. This means that even if the printer is resting, providing the steppers are enabled, you're gonna have all that noise surrounding your print. This is definitely something that we'll have to tackle next, because otherwise that upgrade with Noctua is completely useless. So if you do have original Ender and you would like to make it slightly quieter, don't buy Noctua fans only. It's not going to make that much of a difference to you, and you're gonna end up disappointed. Thankfully, I have a board from BTT Tech, which is SKR Mini E3 version 1.2, and I know this is not the latest board, but I bought it ages ago, and I've been running this board on this printer for a long time, and I think I forgot how good that board is. So when I actually swap the boards out, and it's a very simple swap, all you had to do is just repin everything and you'll be right there, I've discovered that it made the printing much quieter. How quieter, you say? Well, check this out. I honestly could not believe how quiet everything became. I mean, in a resting position I couldn't hear anything, and the only audible sound was when all the axes were moving quickly during homing protocol. Granted, I was running this with Noctua fans set to 50%, which, well, it makes them absolutely quiet. The funny thing about it was that usually the printer is behind me about a meter away, and I could not tell whether the printer is on or off. It was simply too quiet to tell. Everything was going well and really silent until the part cooling fan kicked in, and this thing is, well, loud. You don't usually hear it as much because, well, everything else on the Ender 3 is loud, but this experience realized that we will have to do something about that part cooling fan, because otherwise we're not going to get the silent printing we are all looking for. So with an upgraded SKR boards and all Noctua fan installed, that would raise the price of this upgrade to approximately £80. Something you probably want to consider. Let's put some brakes on Ender 3 right now, because we're going to change the printers and apply the same modification to Ender 3 V2. Just as before, I'm going to need two A410 fans from Noctua, one for the extruder fan and one for the electronics to cool the box inside, and those replacements are straightforward. All you have to do is just power them up with 12 volts, and, well, they fit into place without any problems. But we won't be able to use the same hack we've used on the Ender 3's power supply because, well, it's located at the back underneath the printer itself, and we simply don't have the space. Now the fan is still there. There is still inside a fan, 60mm by 10mm fan, but I have another approach. Instead of going Noctua and picking a 60mm fan, then trying to fit it or maybe move the power supply to the side or create raises, there's a multiple of different approach. I thought I'm going to try something else. I've discovered that there are 400 watt fanless power supplies that I can use that are just about the right size for Ender 3 V2. So this is what I got. I went to the website and I've ordered one of those Minwave power supplies. After checking the datasheet, I knew that the PSU it's not going to be a straight fit. Some modifications are need to be made. And, well, let's start with taking out some grinding tools of your choice. I mean, you don't have to have an angle grinder. Hacksaw will work just fine because the whole case on that power supply is aluminium. But I have to say it was a pure luck that after hacking off all those folded over winglets from the power supply cover, it was just a perfect fit for the existing space for the power supply. All I had to do to make it work is just file down some corners so they don't be so sharp, clean up everything from shavings of metal so they don't cause any shorts, use angle grinder to cut a couple of vents for the hot air to escape using convection heat techniques, and I was ready to fit the PSU inside my existing space for the power supply. As I want to keep everything neat, I also needed to modify that small little plate that covers the wires at the back, but that was easy enough and you'll be able to do it with a hacksaw. At this point it was probably around 1 AM and I was really tired, so you'll notice that my top cover of the power supply is full of holes like a Swiss cheese. Mostly because I really wanted to get that 12-volt power stepper down board bolted on some stands-off as quickly as possible, and then I quickly realized that if I gonna just pick a random place, it's gonna mess everything up and I had to re-drill everything. So anyway, long story short, it took me 3 times to get the right position. It's not perfect, but at least I can assemble everything. So my word of advice: don't make upgrades when you're tired and measure everything to make sure it fits. And since I was already messing with the power supply and the cables and everything, I figured out it's a perfect opportunity to stick a Shelly 1PM Plus inside and enable remote management for the printer, power measurement, etc. That was exactly the same link that I linked you with ND3. So go check it out when you have a spare moment. So with a new power supply, step-down converter and 2 fans, this project brought me closer to £70 in total. So with a new fanless power supply, 2 Noctua A4 fans and a step-down power supply to power them up, that would bring this project close to around £70. Not too bad. So let's find out whether it was worth it. It was obvious that it's going to be quieter, especially that one of the fans is already missing, but I don't think it's as quiet as the one with the SKR board installed. So that's my next step, is to try another controller board. And as it happened a couple of weeks ago, I reviewed the latest SKR Mini E3 version 3.0. This is the board I still have, and I'm going to install this into this printer to find out if it's going to make it quieter. Unfortunately, unlike with original ND3, the swap of the board wasn't as simple, mostly because the Creality screen on V2 isn't directly compatible with the SKR board. I don't know who did what, but in order to make it work with the original screen, you'll have to make a special ribbon cable, swap a couple of pins, and you can still make it work. But as I already have a touchscreen display dedicated for this printer, I'm going to use this instead. I know this adds extra cost to the project, I'm not going to factor that in, but this is something you have to be aware if you're going to take this route. This is with a park cooling fan enabled. I definitely need a new fan for that. It is definitely quieter, but it is also an expensive upgrade to make if you're just looking at the noise levels. Thankfully, this board comes with a lot of different features which kind of help you offset that price and make it feel like you're actually paying for something worth a while. It also means that you're gonna bring the cost of overall upgrade to this stage to approximately £100. We've done a lot of work so far, however we haven't addressed one of the things, which is part cooling fan. But before we actually go to that, we have to talk about flow considerations. Noctua fans are quieter because on average they spin slower than the 24 volts counterpart used on Ender machines. Now that obviously brings less air into the system and can affect printers' performance. In my test I was deliberately running them at 50% of the flow using those PWM controllers supplied by Noctua. Obviously I don't expect you to get those, but each Noctua fan also comes with a cable that reduces the flow of the fan to 70%. It means that you can use this cable to limit the maximum output of the fan to that 70% and keep the fan profile quite quiet. I know my tests weren't particularly thorough. I was running the longest sprint for about 4 or 5 hours at 50%, running PLA Plus at 210 degrees, and I haven't had any problems. There was no noticeable heat creep, there was no blockages, and the prints came out fine. Now your experience might vary because there is so many different variables that you have to take in considerations. So if that's the case, you might be forced to run Noctua fan at 100% instead, but as far as I'm concerned right now on my setups, everything was working just okay. But if that's not working for you and you find yourself affected by a heat creep, then you might want to swap those fans on the extruder for 20mm version of Noctua, which will give you a little bit more flow and perhaps better performance. Obviously you will have to account for the extra space needed to fit them on. It's not a massive problem on the original Ender because you can mount them on the outside, but on the shroud from the Ender V2, well, that'll take some creativity. So why am I talking about the flow now in the middle of the video? There is a couple of reasons for that. The most important one is that we are about to modify part cooling fan, and we're gonna talk about custom ducts. To be honest, I got encouraged by a number of custom ducts available on Thingiverse, even though it went against everything I've learned about fans so far and static pressure. So after designing 2 of my own ducts to test things out, I mounted the Noctua fans and replaced my part cooling fans to give it a go. And surprise, surprise, I was having no air whatsoever. So I rigged up a little test to verify this. Now the stock radial fan was quite good at pushing the air, even if I scale down the voltage back to 12 volts. To confirm that I'm not being biased towards Noctua fan, I also verified the flow this way with the 24 volt fan that is by default present on Ender 3 printers. And as you can see, the amount of flow I was getting from Noctua fans was actually quite decent for both configurations, the 10mm one and the 20mm one. But situation has changed completely as soon as I've added fan ducts. The fans were unable to handle the static pressure, and even when I reverted back to original 24 volt fan, the effect was pretty much the same. In fact, I was getting more force through it in a second configuration than actually trying to push the air through the fan duct. Even with my ridiculous design that would have like this big hole at the end and enable the Noctua A420 to push all the way to the part to cool it, I wasn't really having any air. So don't get fooled into thinking that those things are working. Whenever you're gonna see a fancy duct on Thingiverse, consider what type of fan is it designed for. If it's just a typical bladed fan, then, well, you're not going to get any flow through that. The air simply is going to escape through the blades. And I know that sounds ridiculous, but that's exactly what is happening. So as the Noctua doesn't really have any radial fans, I went to Amazon to quickly source a couple of radial fans. And my thinking behind it was, let's get really big ones so I could downvolt them and run them quietly. So I got myself 2 24 volt radial fans, 5020 and 4020, which is diameter and the thickness of it. Then as I was getting better designing custom mounts for my extruder, I designed a modular one so I could replace the fans and see what works and what doesn't on individual printers. But before that I wanted to verify if those designs that I've made are actually better than the stock parts used for part cooling. Thankfully, as you can see from my experiments, it worked quite well, so all I had to do is just put them on the printer, set them up and start running some benchmarks. So for my original Ender 3 I went with a 40-20 radial fan on a custom bracket. It had enough flow to replace the original fan, so I was quite confident that everything is going to work quite well. As I mentioned before, to run it quieter, I've connected it instead of to 24 volts to 12 volts coming from that customized power supply. That way the maximum speed would be 50% of what this fan is capable of, and I was hoping that, you know, the extra size of the radial fan would compensate for that. It would, but I also discovered one of the disadvantages. Now, while the fan at 100% was absolutely silent, as soon as I started to PWM control it, it would create a little bit of noise. It was an unwanted really side effect of the whole experiment, but other than that I really have no issues with it. It's a noise that I probably wouldn't even notice on the regular setup, so I take it as a win at this time. I was only surprised because on my bench I was using voltage to drive the speed of the fan, and that wasn't giving me any issues. I might actually jump into 50-20 in my next iteration, but for now I only have one of the 50-20 and that goes on my Ender 3v2. So to get to this stage on an Ender 3 you have to spend extra around £100 to get your silent printing. And I know that sounds a lot, and you could probably get a new printer for $100-ish something depending on the promotion, but if you want to enjoy printing in a quiet environment, this is more or less what you have to do. Now for the Ender V2, however, I have something special. I've mentioned before that I've partnered up with BIQU, which not only makes BTT SKR boards, but also makes water-cooled extruders. And what is the better way of, well, silencing everything if not running a water instead of air? Armed with this knowledge, I had to remove the original extruder and replace it with BIQU H2O, H2O, which is water, right? Water-cooled extruder with a direct drive. It's a really powerful beast actually, which I'm going to cover in a separate review. But for now we're just going to focus on the performance in terms of noise. So first of all, what you're getting is a capability of printing up to 500 degrees Celsius. That's a lot. You can actually melt solder with this. But also what you do get is the water-cooled extruder. So you might thinking like, okay, hold on a second. I know that's going to be water-cooled, but you get this massive fan and a pump next to it to hold. And that is true. However, in my experiments I quickly discovered that the water cooling is extremely efficient. Now, even if I was running the print for a couple of hours at like nearly 300 degrees, both tubes supplying and removing water from extruder were, well, the ambient temperature, and I could not tell which one is which means that the entire setup is really efficient. And I've put a Noctua 120mm fan to keep it quiet, and I downclocked the 12 volt supply because it has individual step down from 24 volts to a 12 volts to about 7-8 volts to run the pump and the fan itself almost silent. And just like on the Ender 3, I took the 50-20 radial fan on a custom bracket and I've connected it to 12 volts instead. That way it would be running at 50% of its maximum power and it would be running it silently. Here I had a pleasant surprise because on this particular fan I didn't have the PWM problem that I've experienced on the original Ender. Even when the fan was running at 50 or 70% of the maximum speed connected to 12 volt rails, it wasn't making any additional noises, which was nice because, well, the whole thing is just silent now. Just listen to this. There is one issue though. This setup will cost you £280 on top of the cost of original printer, which means if you want to turn your NV2 into a silent printer, expect to open up your wallet. And I understand that the last level of that upgrade brings probably marginal gains to the sound levels. However, you will end up with extremely cool water-cooled printer capable of printing up to 500 Celsius degrees, which is insane. So what does it mean for me? Now, I'll be able to use both printers, possibly at the same time, without blocking my time for filming videos. This means that the printer can operate in the background and I can still make videos on YouTube without creating extra noise in my videos and making the whole experience unpleasant. And I do understand that, well, in the last stage, £280 is a lot of money to spend to silence your printer, but I promise we're gonna throw the money at the problem in order to squash it, and if you're up for it, why not? Even if it's gonna cost you a second printer. So, big thanks to two of my sponsors for this video, the BIQU and Noctua, who spare no effort to help me out, so do check them out. In addition to this, I have a complete write-up about this linked in the description of this video, so do check that out as well, alongside some tools that you're gonna probably need to complete this, all the funds that I've used and all the part lists too. So do let me know, what do you think about silent printing, and would you rather build an expensive enclosure or would you upgrade the parts, or how would you tackle the noise? And if you have any tips, then I'm open, because the next project I'm going to tackle is probably building an enclosure. So for now guys, if you're interested, you know how to stay in touch, you know how YouTube works. I'm not going to explain any of that, but I do have a social media in which you can get in touch with me, send me links, because YouTube doesn't like really links, and find out about what I'm working on next. So guys, thanks so much for watching. I hope you took something useful out of this video, and I'll see you in the next one very, very soon. Take care. Bye.